Hi, this is Samira. Welcome to session on IP addressing and subnetting. This session would cover all the concepts around IPv4 addressing. We would discuss what is the need for IP address, the different classes of IP address. We would also take a look at what do you mean by reserved addresses or special addresses. Next, we would focus on subnetting, and we would look at the differences between FLSM or fixed length subnet mask versus VLSM or variable length subnet mask. We would also discuss a few examples to understand how to do subnetting using VLSM. And finally, we would discuss the concepts of supernetting or summarization. So let us begin with the session. Let us begin with IP addressing. We will first take a look at why do we need IP addresses. We already have physical addresses or MAC addresses in place. So why the need of a logical layer of addressing called IP addresses? To understand this, let us take an example as shown here. In case if you want two devices to communicate with each other, you need to use some kind of addressing so that the devices are able to speak to each other. Consider that you have only MAC addresses in use. You can take a look at device A and E have got MAC addresses. The MAC addresses, even if the two devices are neighbors of each other, are not related. All of the bits of the MAC addresses do not have any relation with each other just because the two devices are the neighbors of each other. In such type of a case, if a source, as shown here, wants to communicate with device E using just the MAC address, the source will have to create a MAC table, a routing table, and will have to have the destination MAC addresses as well as how to reach the MAC addresses in place. In case where the devices do not have any relation in the MAC addresses, the source will have to keep with it the MAC address of each and every device which is present in the network and how to reach these devices. This is not going to be feasible for a very large network, as the source will have to keep a routing table of a very large size, and that will not be feasible. Also, the routing updates traffic that is going to be present on the network will be very high if you are going to use MAC addresses, using which you cannot create any hierarchy. And hence, there was a logical layer of addressing called IP address that was introduced. You can create hierarchies using IP address. For example, take a look at the network 1 which is shown here. The devices are using IP addresses, and since all of the devices belong to network 1, the IP addresses of these devices are related to each other. That is, you can take some common bits out for each and every device present here, and you can assign a network ID for all of the devices. So network ID is going to be a common ID that would be used to represent multiple devices present in the same network. This is how you can create hierarchies. That is, you can create multiple smaller networks within a huge area. Now, if a source wants to send some data to one of the devices present in network 1, the source will have to keep a routing table, and in the routing table the source will have just one destination, the destination network ID, and how to reach the network. If the source has to reach any device present in network 1, the source is going to send the packets to the next hop which is shown here. Once the message reaches that particular network, the network can route the message to the device present in it. So that is what is going to help you to create smaller routing tables as well as have less number of routing updates in the network if you use the logical addresses, which are IP addresses, since you can create hierarchies. We have got two classes of IP addresses, IP version 4, which is 32-bit, and IP version 6, which is 128 bits. Since IPv4 is a 32-bit address, you can have 2:32 number of addresses possible. But with emerging technologies like 5G as well as IoT, IPv4 is soon going to be exhausted because of limited number of IP addresses. And hence IPv6 was introduced a long back, and we are moving towards IPv6. Since IPv6 is 128-bit addresses, you can get 2:128 number of possible addresses. In this session, we would be focusing only on IPv4 addresses. The IPv4 address is represented in dotted decimal format. So this format that you can see here, this is the dotted decimal format, 192.168.2.1. Basically, the IPv4 address, which is 32-bit binary, is divided into 4 octets. Each octet is represented in decimal format separated by a dot. This is how you would get the dotted decimal representation. Dotted decimal format is just a representation. Computers actually can understand the binary format only. The dotted decimal representation is just for humans to be able to remember the IP addresses easily. Next, let us move on to the classes of IPv4 addresses. The IPv4 addresses are divided into 5 classes: Class A, Class B, Class C, Class D, and Class E. The 5 classes can be represented or differentiated using some fixed bits. In case of Class A, the MSB bit is always 0. In case of Class B, the 2 MSB bits are 1, 0. Class C, the first 3 MSB bits are 1, 1, 0. For Class D, the first 4 MSB bits are 1, 1, 1, 0. For Class E, the first 4 MSB bits are 1, 1, 1, 1. The rest of the bits can vary from all zeros to all ones. This gives you a range of IP addresses for each classes. For Class A, the first octet can range from 0 to 127. That is, first is 0. The remaining bits can range from all zeros to all ones. So for the first octet, you can have 0, 0, 0, 0, 0, 0, 0, 0 up to 0, 1, 1, 1, 1, 1, 1, 1. That gives you the range 0 to 127. Similarly, for Class B, the first octet can range from 128 to 191. For Class C, the first octet can range from 192 to 223. For Class D, the first octet can range from 224 to 239. And for Class E, the first octet can range from 240 to 255. From amongst the 5 classes, Class D and E are reserved, leaving you with Class A, B, C, which are usable IP addresses. The Class D is reserved for multicast addressing, and Class E is reserved for research purpose and future use. In case of Class A, B, and C, there are some fixed number of bits which are reserved for network bits and fixed number of bits reserved for host bits. In case of Class A, you have the first 8 bits which are reserved for network bits, The remaining 24 bits are reserved for host bits. In case of class B, the first 16 bits are reserved for host bits and the remaining 16 bits reserved for the host bits. In case of class C, the first 24 bits are reserved for network bits and the next 8 bits reserved for host bits. This will give you the number of hosts which are possible per network for class A, B and C. In case of class A, since you have got 24 bits reserved for host bits, you can have 2 raised to 24 IP addresses possible per class A network. From amongst a network, the first address is always reserved for the network address and the last address for representing or for the broadcast address. And hence, the number of valid hosts possible per network is 2 raised to 24 minus 2 in case of class A. Similarly, in case of class B, the number of valid hosts possible per network of class B is 2 raised to 16 minus 2. Whereas in case of class C, the number of hosts or valid hosts possible per network of class C is 2 raised to 8 minus 2. Next, let us take a look at the reserved IP addresses. Some of the IP addresses are reserved for some special purposes. Like for instance, the all zero IP address is reserved for this host. If you have got the first few bits or the network bits as zeros and the host bits having some value, that is reserved to represent a host on your current network, that is host on this network. Next, you have got the addresses in the range 127.0.0.0 up to 127.255.255.255. Okay, so this entire range of IP addresses which starts with the first octet 127 is reserved for loopback purpose. Loopback addresses are used for testing. Okay, so if you want to test whether your NIC card or network adapter of your computer is working or not, you would be doing a ping to the loopback address. If you get a reply from the loopback address, that means your network adapter or NIC card is working fine. Next is the local broadcast. The all ones address, that is 255.255.255.255 address is used for local broadcast, that is broadcast within your current network. Next, you have network addresses. This address is going to be reserved for each and every network that you use. For any network that you use, the network bits kept as it is and setting the host bits to 0 will give you the network address for that particular network. So for instance, if you are using an IP address 120.5.5.5/8, then in that case you have got 8 bits as network bits. So keeping the 8 bits as it is, if you are going to have the rest of the bits set to all zeros, giving you 120.0.0.0, this would be the network address for that network in which your host 120.5.5.5 belongs to. Next is the broadcast address. To get a broadcast address for any network, you need to keep the network bits of that network as it is and put all of the host bits of the network to 1. So for instance, your host which is 120.5.5.5 which lies in the network 120.0.0.0, For this network, the broadcast address would be 120 dot rest of the bits set to 1, which would give you 120.255.255.255. So that would be the broadcast address for the network on which your host 120.5.5.5/8 lies on. Next, let us move on to public versus private IP addresses. Amongst the entire set of IPv4 addresses, few of the addresses are reserved for private IP addressing. The private IP addresses can be used within an organization without any requirement for registering. The private IP addresses can be reused by several organizations, or it can also be reused by the same organization for its different LANs. The private IP addresses are not routable over the internet. The private IP addresses which are reserved are for class A, we have 10.0.0.0 to 10.255.255.255, which is 10/8. For class B, we have got the address 172.16.0.0 up to 172.31.255.255 reserved for private addressing. Similarly, for class C, we have got the addresses in the range from 192.168.0.0 up to 192.168.255.255 reserved for private IP addressing. The public IP addresses are registered as belonging to a specific organization. Whenever any organization wants to use a public IP address, it has to register that IP address with some appropriate authority like RIPE, ARIN, or local internet registries. All of these addresses finally get registered with IANA, which is Internet Assigned Numbers Authority. The public IP addresses are routed across the internet. Next, let us move on to subnetting. A subnet is a logical grouping of connected devices. So for example, you can consider a big network 192.168.1.0/24. This is a class C network. This has got 24 network bits and 8 host bits, and hence it has 254 hosts in this network. There might be a possibility wherein you want to have smaller networks. Okay, so 254 hosts is the smallest network possible if you consider amongst the rest of the classes like class A, class B, class C. Amongst these, you have got the smallest, which is provided by class C, which gives you 254 hosts. But if you wanted a network of, say, one of it to be of 20 hosts, another one of 50 hosts, and so on, for such small requirement, if you are going to use a single class C network, it is going to have a lot of wastage of IP addresses. Okay, so in order to avoid wastage of IP addresses, and also for ease of administration for smaller networks, you would rather prefer dividing the entire big network into small parts. Okay, so when you divide this big network into smaller parts, that is called as subnetting. So in this example that you can see here, my big network of 254 hosts is divided into 2 smaller networks, each of 128 hosts each. Next, let us take a look at how to create subnets. In order to create a subnet, you need to divide the large network into small parts. Okay, so you need to have less number of bits being used for your host portion and more number of bits for representation of network. Okay, so for example, if you consider a class C IP address, okay, which is 192.168.1.0/24, here you have got 24 network bits and you have 8 host bits. And hence this is going to give you 2 raised to 8 number of IP addresses. Okay, if you need less number of IP addresses, then in that case you can have less number of bits for representing host. Okay, so for example, if you want to divide this network into two subnets, then in that case you will require one additional bit for representing the subnet. Okay, this is what you are going to borrow from the host portion, and the host portion will have one less, that is, it will have 7 number of host bits remaining. So that is going to give you 2 subnets and 2 raised to 7 number of host IP addresses. Okay, so we will just take a look at how this is being done. So consider your IP address 192.168.1.0. Okay, and this is your /24 network. So this has got 24 network bits and it has got 8 host bits. Okay, so since you have got 8 host bits, the number of host IPs possible is 2 raised to 8. Okay, and from amongst this, 2 IP addresses are going to be reserved, one for the network address, one for the broadcast. So you'll subtract 2, which will give you 254 addresses. So these are going to be 254 valid host addresses which are possible if you are going to have 8 host bits. Okay, and now consider that you want to subnet this. Okay, so you need 2 subnets. Okay. Now if you need 2 subnets, you will need 1 bit for subnet. Okay, so whatever is your 1 bit for the subnet, that bit, when it takes a value 0, that is going to give you for first subnet. When this bit takes the value 1, it will give you the second subnet. Okay, so if you need 2 subnets, you require 1 bit for representation of subnet. Okay, now you have got 8 bits for your host part. So you have 192.168.1. This can be expanded into 8 zeros. Okay, so from this you have got 8 bits reserved for host bits. Okay, so 1 bit out of this, which is the MSB, which is closest to the network bits, this you will use for representing your subnets. Okay, so if you use this for representing your subnets, you would be left with 7 bits for your host. Okay, so this is going to give you number of host bits equal to 8 minus 1. Okay, because 1 you are going to give it for representation of your subnet. So number of network bits would be is equal to 24, which were your network bits earlier, plus 1 subnet bit. So this will give you 25 network bits. Okay, so when you subnet this address into 2 parts, you will get 25 network bits and 7 host bits. Okay, so when your subnet bit is equal to 0, that is going to be your subnet 1. Okay, and this subnet 1 range would be 192.168.1 dot. The first bit is your subnet bit, so you are going to give first place the subnet bit to be equal to 0, and the rest of the host bits, all 7 zeros. Okay, so this is going to give you the network address for subnet 1, and we will find out the broadcast address for subnet 1, which is going to be 192.168.1 dot. The subnet bit is 0 and the host bits are going to be all ones. Okay, so your broadcast address is basically when you put your host bits to be equal to all ones. The network bit are going to be as it is. Okay, so this subnet 1 network address is going to be 192.168.1.0. This would be /25, because now you have got 25 network bits, and you will have the broadcast address to be 192.168.1. The first one 0 and the rest of all ones will give you 127. Okay, so we are just converting this binary to decimal. This would be /25. This is the broadcast address. Okay, and hence you can say that valid host range for subnet 1, okay, the valid host range for subnet 1 is going to be from 192.168.1.1/25 up to 192.168.1.126/25. Okay, that is in between these two. Next, when your subnet bit is equal to 1, you would get your second subnet. Okay, so this is your subnet 2, and your subnet 2 would have the network address 192.168.1. Your subnet bit is now 1. So this bit is now 1, and your host bits, since we are going to find out the network address, your host bits would be all zeros. This is going to give you the address in dotted decimal format as 192.168.1.128/25, and you will get the broadcast address when you put all of the host bits to be equal to all ones. Okay, this is the broadcast address. So that when converted to decimal will give you 192.168.1.255/25, and hence you can say your valid host range for subnet 2, this would be from 192.168.1.128, or this would be 129, because 128 is reserved for network address. So the next one can be used for your host. So you have got 192.168.1.129/25 ranging up to 192.168.1.254/25. Okay, so this is how you can create subnets. Next, we will take a look at what do you mean by FLSM and VLSM. FLSM is fixed length subnet mask. In case of fixed length subnet mask, you can divide your network only in equal sized subnets. Okay, so if you want to have a class C network divided into two parts, you can only divide it into two equal parts, right? So if you have got 256 hosts, then in that case, when you divide this into two parts, you can divide it as 128, 128. That means all of your subnets would have the same subnet mask. Then we say that it is FLSM. For example, if you wanted to divide your class C network, say into 4 parts, then in that case you would divide it as 64, 64, 64, 64. Okay, so you cannot have a division wherein you have got one big network, one big subnetwork. Say this is 128, next I want 20, next 20, next 20. So that is not possible in case of FLSM. Whatever network ID, network address you take, you can only divide it into equal length subnets. And hence FLSM is not widely used, as there would be a lot of wastage of IP addresses, because very rarely would you get a requirement where you need all of the subnets of equal length. So in such cases you would be using VLSM, which is variable length subnet mask. Variable length subnet mask lets you divide your network into variable sized subnets. So for example, if you have got one large network, say of 128 IP addresses, that is 126 valid host addresses, and the other part needs just 16 addresses. Okay, that is 16 IP addresses, or we can say it requires 16 minus 2, which is 14 valid IP addresses. Okay, so this is one of the example that I have taken, wherein I have got subnet 1 which requires 100 hosts, subnet 2 requires 10 hosts. Okay, so this type of requirement would be done optimally using VLSM. If you would have used FLSM in this case, then in that case subnet 2 would also be allocated 128 addresses. Okay, that means you would have wasted around 126 minus 10. Okay, because only 10 would be used out of 126. So 126 minus 10, that is 116 addresses would go wasted. But in case of VLSM, you can have 16 addresses being used. That is, you can have 14 usable addresses allocated to subnet 2, which has reduced your wastage tremendously. And hence VLSM is going to help you to utilize your IP addresses more optimally. Whether you use FLSM or VLSM, for creating subnets, you would borrow bits from the host part for representing your network. So we will take one example. Consider an IP address 192.168.0.0/24. Okay, so this is a class C IP address. Okay, so it is going to have 2 raised to 24 minus 2, that is 254 hosts available. Now suppose that you want to divide this entire network into smaller parts of variable length. So you have got one of the part which requires say 100 IP addresses. The other part requires say 50. Okay, I require 50 hosts and I require 100 hosts. And I also have say the third part which requires say 4 hosts. Okay, so this case is possible if we can use VLSM. So using VLSM, you can have all of these accommodated into same class C IP, class C network. So we have got subnet 1, which has got a requirement of 100 hosts. Then I have got subnet 2, which has got a requirement of 50 hosts. And I have got subnet 3, which has got a requirement of 4 hosts. Now in order to get 100 valid host IP addresses, I would require to have 2 raised to 7, which is 128. Okay, that is I require 7 host bits. So you are going to calculate the number of host bits as, if my host bits are x, 2 raised to x should be greater than 100. Okay, and you have to take x value to be optimum. That is, you can get 2 raised to 8 also, which is greater than 100, right? But it is going to waste lot of IP addresses. But the less amount of wastage would happen if you take x as 7. That is, you can get 2 raised to 7, which gives you 128, and minus 2 for 1 for your network, 1 for your host. Okay, so this will give you 126 valid host. Okay, so you will consider hence take 7 bits or 7 host bits. Okay, and you already had got 8 host bits. Since you had got class C IP address, this gave you 8 host bits, which gave you 254 hosts. Now from amongst 8 host bits, you are just going to utilize 7 host bits for your subnet 1. Okay, so you are left with 1 bit for subnet. Okay, and that is going to give you host bits equal to 7 and total network bits, that is the earlier network bits plus 1 subnet bit. So that is going to give you network bits equal to 24 plus 1, which is 25. So using this, you can calculate your subnet 1 range. Okay, that is, we will calculate the network address and the broadcast address. So the network address for subnet 1 is 192.168.1. Here I have got the first bit as the subnet bit, which is 0, and rest of the host bits as all zeros. This is your network address, which is going to be equal to 192.168.1.0/25. And then you can get the broadcast address as 192.168.1. You are going to have first bit is your subnet bit, which is 0, and rest of the 7 ones. So this will give you the broadcast address, and you are going to have your broadcast address as 192.168.1. Okay, so this one is 0. So I have taken it 1. So I'll just change it to 0. (192.168.0. This is 127/25. Okay, so this is your network address, this is your broadcast address. Next we will move on to subnet 2. In case of subnet 2, you require 50 hosts. That is, you need 2 raised to x should be greater than 50. Then in that case, you can take the x value (2 raised to 6). Okay, so 2 raised to 6 is going to give you 64. So 2 raised to 6 minus 2 will give you 62 valid host bits, valid host IPs possible. Okay, and hence you would take your host bits equal to 6, and then you are going to be left with 2 bits, because you had got 8 host bits in case of class C. From that you are just going to use 6. So you are going to be left with 2 bits. That 2 bits you can use for subnet. So 2 bits for subnet. Okay, that is going to give you your total number of network bits to be equal to 24 plus 2, which is 26. And hence you can calculate the network address for your subnet 2 as 192.168.0. Now remember that you already have used 192.168.0.0 up to 192.168.0.128. So this is already used. You cannot use addresses from this range again, otherwise there would be an address overlap, which is not allowed. Okay, you cannot create address overlap, and hence you can use address only after this broadcast address, okay, which would give you 192.168.0.128. Okay, you simply add 1 to the broadcast address of previous subnet. That will give you the network address for your next subnet. Okay, so this would be 128, which is actually the first bit 1 and rest of the bits as zeros. So this is 192.168.0.128, and here I have network bits as 26. So this would be /26. Okay, now you need to note that you have got 2 bits for subnet. Okay, so while calculating the broadcast address, you need to keep these 2 bits as they are. Only the host bits would be put to all ones. Okay, that is, these 6 bits you will put to all ones to calculate the broadcast address. So your broadcast address is going to be 192.168.0. You are going to have 10 kept as it is. Okay, so the first 2 bits as it is, and the remaining bits are going to be put as ones. Okay, these are your host bits. You have got 6 host bits, right? So I have put all these 6 bits to be all ones. So you need to convert this into decimal format so that you can get your broadcast address. This is 192.168.0. For calculations, you can make use of your calculator in programmer mode. So you can change your mode to programmer. You have the binary 1 0, 1 1 and 4 ones. This you are going to convert to decimal, which is 191. Okay, so this is your 191/26. This would be your broadcast address of subnet 2. Then for the third subnet, wherein you have got 4 host bits, so you are going to have 2 raised to x should be greater than 4, which will give you, you cannot have equal to, okay, because you require 2 additional bits, one for representation of network and one for use for broadcast. Okay, one will be used as a network ID and another will be used as a broadcast address. Okay, so these 2 addresses would be reserved, so you cannot have this equal. You need to have 2 greater than. Okay, 2 raised to x should be greater than 6 in this, should be greater than equal to 6 in this case. Okay, so for that your x value can be 3. Okay, so 2 raised to 3 will give you 8, minus 2 will give you 6. Valid host. Okay, so you have your host bits equal to 3. So this 3, this is your host bit. Okay, your host bits are equal to 3. So if you are going to use 3 bits as host, you had got 8 bits available. Okay, so from these 8 bits, 3 bits you are going to use for host. So you are left with 5. So you have got 5 bits for subnet. Okay, and total number of network bits now is going to be equal to, you simply have to add up these 5 to your earlier network bits. So you have got network bits equal to 24 plus 5, which is equal to 29. Okay, so you have got 29 bits for network. So in that case, your subnet 3 network address is going to be equal to 168.0 dot, here you have used up till 191, so you can start only from the next one. Okay, that is 192 onwards. So you have 192 slash, now this is 29 bits for network. So this is slash 29. Okay, and this can range up to 192.168.0 dot. Now you have got 5 bits as subnet. So your 5 bits will stay as it is and remaining bits will be set to all ones. Okay, so 192 is basically 11 followed by all zeros. Okay, but for your for your broadcast address, you will have your 5 bits kept as it is. So you will have 11000 and rest 3 ones. So this would be your broadcast address. So we will just convert this into decimal. We have 11000, which are my 5 bits for subnet, and 3 ones, which are my host bits, put 2 ones. So the decimal is 199. So this is going to be 192.168.0.99/29. So this is my broadcast address. The subnet 1 address is 192.168.0.0/25, and this ranges to the broadcast address 192.168.0.127/25. The subnet 2 address is 192.168.0.128/26, and this ranges to the broadcast address 192.168.0.191/26, and the subnet 3 address ranges from 192.168.0.192/29, and this ranges to the broadcast address 192.168.0.199/29. So this is how you can do VLSM. Next, let us move on to route summarization. Route summarization or route aggregation or supernetting all mean the same. This is used to reduce the number of routing updates in the network. That is, the routers are going to perform route summarization so that they need to have less number of advertisements going out. Like for example, take a case here, my router has got 2 networks connected to it, 10.10.1.0/25 and 10.10.1.128/25. Okay, so without using supernetting, this router would have to advertise 2 networks out from this interface. Okay, that is, it will advertise this as well as this to this neighboring router. But with route summarization, these 2 can be summarized together into a single advertisement that will go to this router. Okay, so this is going to reduce the number of update traffic that is going to be sent by the router to other router. Also, this will reduce the number of routes present in the routing table for the neighboring router. We will take a look at how the summarization is performed. So this is the example that I have taken. You can see these two IP addresses. These are summarized together into this single address. Okay, so how this route summarization is performed? You are going to take the 10.10.1.0 address, okay, and this 10.10.1.0 and 10.10.1.128. These two addresses have got first three octets the same. The difference is in the last octet. Okay, so we will expand the last octet, which is all zeros, and the network address of the next network, which is 10.10.1.128, which is first one, and the rest of it 0. In order to do summarization of these two, you will take a look from the left hand side to right hand side, which are the common bits and up to where you have the common bits. As soon as you have got uncommon bits starting, just divide it. Okay, so this part is common bits. From here my uncommon bits start. Okay, so you consider your common bits as your network bits and your uncommon bits as your host bits. Okay, so this is going to give you 10.10.1.0. Okay, so up to this is my network. Rest of my bits are to be considered as host bits, and since I am calculating the network address, I am going to put all host bits to be equal to 0. Okay, this gives me the address 10.10.1.0 / count the number of network bits. This is 3 octets, which is /24. Okay, so this is going to be my network address, my summarized network address. Okay, we will consider one more example. So here also you can see I have got 3 advertisements which are coming to this router. Okay, so these are the 3 networks present which can be reached via these 3 interfaces. Okay, so this router needs to advertise information about these 3 networks to the corporate network. So this router, instead of advertising 3 networks separately, is going to summarize the advertisements into a single advertisement. Okay, so you can have your advertisement for 10.10.1.0, 10.10.2.0 and 10.10.5.0 clubbed together into a single advertisement. So in order to supernet these 3 networks, you are going to write down these 3 networks addresses. Okay, so here you will see which is the uncommon part. You have the 3rd octet which is not common, so you need to expand the uncommon octet. So this is 10.10.1 is this, followed by 0. Then I have 10.10.2 is 00000010.0, and I have 5 which is 10.10.0000. Then I have 0101.0. Okay, so I need to supernet these. So I am going to take a look at which are the common bits from my left hand side. Okay, so till here I have got common bits and then I have got uncommon bits starting. Okay, so these are going to be my network bits and the rest of them are going to be my host bits. Okay, so I am going to have my supernetted network as 10.10. This is all zeros, and after these I am going to put my host bits as zeros in order to get the network address. So this will be 0.0 and / number of network bits, these 2 octets, which is 16. This is 17, 18, 19, 20, 21. So this is /21. The 22nd bit is different, right? So it is not common for these 3 networks. So the difference starts from the 22nd bit onwards. Hence I am going to consider only 21 bits to be my network bits. Rest of the bits I simply put them equal to 0, since I need the network address for my supernet. Okay, so that is how you can do supernetting. So we have come to the end of the session. Thanks for watching. Please leave your comments. It will help me to make better videos for you.